Hi, this is Jade Xu from University of Memphis. Today I'm going to use the example to show you how to run multiple linear regression in SPSS. In this example, the researcher wants to find out whether there's a gender gap in faculty salary. So she got a random sample of faculty members from four-year institutions in New England area. And based on the literature, she used the annual income measured in $1,000 as the dependent variable. And also, she included highest degree type, years teaching in higher education, and years on current job, along with gender as the independent variable. After data cleaning and preparation, the final sample size 525. Because the sample size is relatively large, alpha equals 0.01 is used in this multiple regression analysis. Here is the data set. We have the ID number, sex, highest degree type, years teaching in higher education, years on current job, salary, along with race. And for this multiple regression analysis, first we need to make sure that there is a linear relationship between the independent variables and the dependent variable. So we start with graphs, and we find the place for scatter plot. And since we have three continuous independent variables and one dependent variable, we're going to use the matrix scatter plot. I'm going to put the highest degree type, years teaching in higher education, and years on current job, along with salary, into this place called matrix variables. Then click OK. You can see that since highest degree type is a ordinal variable, you don't really see a continuous pattern, but this do not show we have violation against linearity. And since we have large sample sizes, so the scatter plot is not really clear, but at least we get a sense that we do not have a violation against linearity. So we can move on with analysis now. To run multiple regression, we come to Analyze, Regression, Linear, and academic year salary is the dependent variable, and we're going to put in the highest degree type, years teaching, and years on current job as the independent variable along with gender. Then we come to this place called statistics. We want to request the descriptive information along with this thing called collinearity diagnostics. Remember that in addition to linearity, we also have two more assumptions, normality and homoscedasticity. And we can check those two additional assumptions by requesting additional scatter plots. So we come to this place, plot, and you want to first check you have the histogram and normal probability plot. Both of them are used to check the assumption of normality. To check the assumption of homoscedasticity, we're going to do this. We're going to put the standardized predicted values on the x-axis, and also we look at the residuals and put on the residual on the y-axis. All right. Now let's run the analysis. And here's the output. For all 5 variables, we have their descriptive information in the first table and their Pearson correlation in the second table. And when we get the output, the first thing we need to make sure is this linear model explained a significant amount variance in the dependent variable. Here is the annual salary. So looking at this table model summary, you find the R-square is 0.264. That means about 26.4% of the variance in faculty salary can be explained by the linear combination of the 4 independent variables. Is this value statistically significant? The answer is in this table, ANOVA. If you take a calculator, you can find out the ratio between the sum square regression and the sum square total happen to be exactly the same value as the R squared. So this particular ANOVA table is testing the hypothesis whether this R square is significantly different from 0, or you can see whether the multiple R is significantly different from 0.